Hello and welcome to the DassaultSystemes vendor session at the Modelica conference 2021. We are going to talk about a couple of different topics. We will start with Daimler, what has happened in the recent past and in the future, integration into CATIA and other simulation environments, and then we will finish about standards and the outlook of future development. So let's start with Daimler, what has happened in the recent releases and what will happen in the next release. A couple of releases back, we introduced a user interface to the parameter sweep, which we have recently updated with an improved user interface. Also, it runs on multiple cores, so it's really efficient. But one of the things we learned was that adding a user interface to some existing functionality that was more hidden really paid off and was really valuable to our customers. So along the same lines, we have now added a user interface to the steady state solvers in Daimler. So it comes in two flavors. The first, static steady state finding, where you simulate it to time zero. And it does all the initialization and event iterations and solves equation systems and so on. There are a couple of options. You can set the default steady state, that is to set there of x to 0. You can remove any fixed equals true attributes from continuous variables. It's possible to compare the steady state solutions of different parameters. And you can add a check that steady state was really achieved at the end. The other flavor is dynamic steady state solving, in which case we just simulate the model until steady state is achieved. It automatically checks the derivatives of all states. But it has the limitation that it does not detect periodic steady states or a subset of states which have reached steady state. With the options, you can decide only to write the final data point. Again, you can compare the steady state solutions, and also you can set the tolerance for checking the steady state. With regards to plotting, we have made a couple of enhancements. For example, we added bar charts and filled area plots as marker styles. And we have also added an external plotting, which means that you can display PNG or SVG file or active HTML content in Daimler. In this case, it's a plot generated by a plotly in Python that we display inside Daimler. Another plotting feature that we added recently is a discretized plot. So you can do a discretization of some physical object along a dimension, for example, to plot the temperature distribution of a pipe. And the plot allows you to combine several components or arrays of variables in one plot. And then you use the animation slider to show the data values at different time points in this plot. With the functional mockup interface, we have made several improvements. The first one was to add a dialog for FMU import that allows you to select exactly which signals you want to expose in the Modelica model and which ones you want to hide. We also added support for directional derivatives for co-simulation and the possibility to linearize FMUs. Then we added the same interface for selecting signals when you export FMUs, so you can decide exactly which signals you want to expose in the generated FMU as a complement to the filtering on input. We support the Modelica standard library 4.0.0. That is a new release of the Modelica standard library based on the most recent language specification, and it contains a really big number of improvements, bug fixes, and clarifications. One of the major improvements is that it now includes the Modelica clock library, formerly known as Modelica Synchronous, that allows you to implement clock systems in Daimler. And in this example, we have separated the feedback controller, and it runs with an implicit Euler solver, whereas the rest of the model uses the default multi-step solver. Migration to MSL4 is pretty straightforward. There are automatic conversions of models when you open them in Daimler. We have migrated all our libraries to MSL4, and it went really, really well. But if you really want, MSL3 is also compatible with recent Daimler versions. We now support early SSP support, system structure and parameterization. So you can import an SSP file that contains interconnected FMUs and hierarchical SSPs, and also some simple inline parameter bindings. And it creates the corresponding Modelica model that is then ready for simulation in Daimler. Microsoft recently introduced what is called as Windows Subsystem for Linux, WSL. So using a microkernel in Windows 10, it's possible to run Linux, typically Ubuntu or Kali Linux, and it works really well. And we have integrated that in Daimler, so you can now use the Linux compiler under WSL to compile your models and run simulations. It's fully integrated and works straight out of the box. It can also be used for cross-compilation between Linux and Windows. So you run Daimler in Windows, but you can generate FMUs that contain binaries for both Windows and Linux directly. A couple of new libraries, for example, the Aviation Systems library contains models of aerodynamic models of aircraft and drones. It uses standard MSL interfaces and allows you to integrate into with other libraries, for example, for electric drives, batteries, and so on. So compared to our flight dynamics library, the Aviation Systems library is designed to be very easy to integrate with other libraries and MSL, which allows you to do mission planning and analysis of energy consumption. On the other hand, the Flight Dynamics library has more sophisticated aerodynamic models and can be integrated with the other tools, for example, flight gear for visualization in a flight simulator. We will also release a MultiflashMedia connector library that allows you to use solvers and fluid data from MultiFlash directly inside Modelica models. And it's very well integrated as a drop-in replacement for the media packages in Modelica.
Thank you very much, Dag, for this impressive overview of Daimler evolution. We will now give the mic to Xavier, who's going to talk about integration in CATIA.
Hi, my name is Xavier Raymond and I work in DassaultSystems R&D. I will give an overview of the links between Modelica and DassaultSystems applications in a 3D Experience platform. In a 3D Experience platform, Daimler Behavior Modeling application is available to author and simulate Modelica models. It is based on the same software kernel as Daimler standalone application. Thus, Modelica models and Modelica libraries are fully compatible with both applications. 3D Experience Platform also includes other apps for 3D modeling in domains like mechanical design, piping and tubing design, or HVAC design. Virtual twins of the systems can be created by combining those models with Modelica multiphysics behaviors. Platforms, lifecycle tools, and collaboration tools can be used to manage the created data. The 3D Experience platform also offers solutions to optimize the models thanks to automation, multi-scale simulations, process workflows, and results analytics. Now, we will see examples of workflows for models development integrated in the 3D Experience platform. First, the piping and tubing 3D models are developed in the context of complete digital mockup. Systems simulation is also integrated in the platform with our Modelica technology and industry-proven Modelica libraries. 3D simulations are also available, powered by Simulia technologies, including, for example, CFD or FEM. From the 3D models, 1D models are automatically created for the purpose of systems simulation. Other evaluations of the design, like thermal or NVH analysis, can be performed with the 3D simulations. Finally, 1D and 3D simulations can be coupled in various ways in order to study new scenarios and to compute even more accurate results. 3D Experience platform includes schematics applications. In this workflow, we selected a piping and instrumentation diagram. In order to prepare simulation, the first step consists in selecting the schematics, then selecting the P&ID items to be included into the simulation scenario. Then, those P&ID items are mapped with Modelica classes, including mapping of parameters and connectors. Once those preparation steps are completed, the simulation model can be generated. In Daimola behavior modeling application, the generated model can be extended with boundary conditions or control logics, for example, in order to finalize the definition of the simulation's scenario. Once the model is ready, the simulation can be launched, either for single use case or multiple runs for optimization or any design of experiment. Finally, results post-processing is performed with various available tools. When the initial P&ID model is modified, only steps 5, 7, and 8 need to be repeated. Okay, let's have a more concrete example with that demonstration. This application is a firefighting system. We will focus on the P&ID. In Daimola behavior modeling application, the P&ID items are mapped with Modelica classes. A default mapping with most standard types of piping items is provided. The mapping can be done by dragging the Modelica class and dropping it on the reference item. In the pop-up dialog, the connectors and the parameters are mapped. Next step is to select the pieces of equipment, the piping parts and the pipes to be included in the simulation. The items can be selected individually. Each piping line can be selected in one click. In this example, some valves are bypassed and they will be represented by connections in the Modelica model. Now we can generate the simulation model. From that generated model, a first simulation now can be started with the default values. This second demonstration is about vehicle cabin thermal control application. A detailed 3D model of the cabin is used to accurately capture complex fluid thermal interactions. The power flow solver resolves the convection effects. This is coupled with the thermal solver, PowerTherm, which resolves the conduction and radiation behavior inside the cabin. The HVAC unit into the 1D system model is coupled with a 3D model to obtain the evaporator outlet temperature. The 1D system model also includes the electrified powertrain and the battery of this electric vehicle, so the impact of the cabin thermal control on the battery range can be evaluated.
Thank you, Xavier, for this impressive demonstration, and we will now leave the floor to Guillaume, who's going to present us our Modelica cloud simulation solution.
Hello, this is Guillaume Terpent. I am CATIA System R&D Portfolio Director, and I will present to you here in this conference the Daimola online offer, so our web offer, which is either cloud or on-premise. So first, I'd like to locate this offer in our more global system simulation framework. Of course, I limit here the scope to the Modelica framework, while we have a larger portfolio in DassaultSystems. But so in Modelica, we have two applications that you are probably familiar with. So Daimola standalone and its counterpart integrated in a 3D experience platform, leveraging so also called DBM, and leveraging the other application of CATIA. There are our libraries with our services team helping to deploy our solution. And we have also some tools that are dedicated to FMI. And then, so what we are providing here is our system simulation application, leveraging the exact same kernel as Daimola, and which aims to democratize the usage of these solving technologies with an easy explore and experiment of models. So what is the process? So the process is as typically we would see our traditional users, whether they are using Daimola or again its equivalent in the platform called DBM, to create models or libraries. And then you would pass it on to a designer, and the designer is already a web users and would be able to do model composition and customization. So to first run the model and tune it and prepare an experience so that a designer the designer can send over and share a template to an analyst. The analyst then has less capacity of changing the model because he's not supposed to understand in depth the model, but he will be able to run, to consume these models, and to post-process and generate reports. So, of course, he's able to send back. We have ways on me to send back to the developer information so that the model is potentially changed if needed. So if we look at this in another view, so the developer is a technical Modelica expert. He creates model, and so we're really familiar with this population. We have the designer who has to understand some of the technologies behind Modelica, but is usually more domain expert and really trying to model exactly what he knows in his discipline with thanks to library provided by the developer. Then he prepares template or simulation template to an analyst, and this analyst is unable to change the parameters on run, but is usually someone less expert, can be, for instance, someone looking at non-regression or variation around some point usage, and then to generate reports. So the system simulation designer compose, parameterize, simplify, and share. This is just to simplify, and this offer is available since Q3 2020 cloud only. We are more and more developing our offer on the cloud in the first place. And as there were some requests to have similar functionalities available on-premise for our customers, we are currently delivering it, so it will be available toward the end of the year with our 22x release. And the price range is expressed in PSC, so the equivalent of the classical PLC contract, but S standing for subscription, and it's about 75k euros of acquisition, and you have the full access of as many runs as you want operated on our cloud. And so if you look at the two solutions, so System Simulation Designer and System Simulation Analyst, clearly there is a full inclusion of System Simulation Analyst in the functionalities are all included in System Simulation Designer capacities. And this is a subset for with intent to diffuse this to again a large population. So for that we are providing a price point which is fairly low, because we're talking about 1.5k to have an access of 250 run each year. We computed that to be, say, around one run a day for casual users. And of course, any of these users can benefit from packs of credits that could be acquired for a group of people, of 4,000 additional credits of run that would be available. So this should allow a diffusion of the Daimola technologies in areas where it was not very diffused due to the lack of specialists. So now it's probably time to look at it in action. So if we look at what it means, so it all starts pretty classically from our dashboard, and from this dashboard you will be able to load a model by a simple drag and drop, and then navigate in a very similar way as what you're used to in the in Daimola, for instance. You have access to all the parameters in this designer environment. So this is a system simulation designer in that case, which is shown. And what you are able to plot all variables. And what you will do then is prepare the template as it was as we talked about earlier. And the preparation of this template, called Cockpit View here, will provide you, will preset all the data on which the analyst can play for loading some replays. And so when the sheet is ready, it's ready for sharing with the population of analysts. The exact same interface is available online again, but from any device which would have a browser. We are currently making some modification to make it even easier to manipulate with a touch screen.
Thank you very much, Guillaume, for this presentation. This is really a pretty nice product that we are putting right now on the market, and that may really change the game we used to play with the system simulation from the past years. And this is a perfect introduction to the Dassault System vision and ambition that I'm going to present right now through some standards and outlook. But first of all, I should have introduced myself. My name is Bruno, and I am Multiphysics and Control Design R&D Director at Dassault System. But before talking about Dassault System ambition and about the future, what I would like to say is we are continuously and still investing inside Daimola. Just because having a leader position on some domain, especially on the Modelica compiling and execution environment, is not sufficient. So we want to do more. We want to keep that position and have a better translation capabilities and execution capabilities, but that's a low-hanging fruit, and I won't go too much in detail for that because Dag already did. And we want to continue invest in that compiler, and you will understand why, because that's gonna be the heart of the fuel system simulation offer we want to provide. And for that, we also need a huge set of libraries. And for that, we will continue investigating in new topics, new domains, improving the current library we do have for sure, but also trying to have it in other different domain. And at Dassault System, we have the capability to do that in several different domains, especially in healthcare, which is unfortunately a pretty good subject to work on today, but that's where we want to go. And for that, we will continue to keep the good effort we are doing on DBM, as Xavier presented, and trying to link that with all other platform domain we can that can be part of the activities, and also from this web-based simulation that Guillaume just presented. And for that, we will rely on standard and on some project, and part of them are supported by the Modelica Association, which means we will continue doing efforts and putting resources on those projects, from which I will mention SSP, EFMI for sure, and FMI. As that has become a full standard right now. But let me put some light on EFMI today, just to say that this is not only words, and we actually have real activities on these capabilities and on this project. We used to be part of the emphasis project. For that, we start having a whole tool chain in the platform that is available, starting from Daimler, that will allow you to draw your physical model, and the capability to translate that to this GALEC algorithmic language. And then go down to ESP, which is another CATIA product, which is software producer, which allows you to product a C code or any binary code. So from GALEC for sure, but for also other languages. And then we have the capability to test all that and to do really close to the target binary production, thanks to AutoZar. And for sure, there is even more to come. So this is the kind of combination we can offer in Dassault Systems. So based on the standard that is developed, like EFMI, we will combine some of our tools to make this real and accessible to real engineers. And of course, all this is already available through prototypes. So this means that this will be released in our product in the near future. But by combining standards, I have a dream in DS, and this is not only me, but the entire company. We want to provide an holistic platform approach for engineering. And inside engineering, there is system engineering, simulation engineering, and so on and so on and so on. So we have this behavior simulation that you all know by heart, and this is all the tools that were presented up to now with SID again, with DBM, and with Daimler. But we want to have the full end-to-end approach. So starting from requirement engineering, which is not the heart of Modelica for sure. But just imagine some places where you can have requirements that are stored. Maybe some of them could be executed, and we have that technology at Dassault System, thanks to Stimulus. And then you allocate those requirements into some architecture, so that you know where your requirements are allocated, and maybe you can play the full architecture at the requirement level. So thanks to some representation, very standard like SysML, for instance, and then the ability, when we link to system behavior, to compare that what has been designed and implemented in Modelica is really coherent with the requirements. And then you start building a full path from requirements, thanks to the simulation architecture, then down to the design, should it be 3D, 2D, or to down to the validation and the testing, so that you can, through the simulation, manipulate all that. So that's the big dream that we do have. And you can also add some really transverse activities around, like traceability, safety analysis, or some others like project management or variant and variability. And now you have a big picture where all this activity can all be performed together. But what if we take a more focused approach on simulation, I mean system simulation? Guillaume just showed you what SID can do on Modelica models, but let's have a bit of more ambition here, where we will be able to build an architecture, thanks to some other standards like SysML, And then inside of each and every block that you see here, put some Modelica for sure, some whatever language like Python, PLC Open, or whatever, some state machine from the CSML standard, let's say, and some requirements that are executable. Um, wouldn't it be nice to have a global simulation environment that can manage all that all together? And for those who are following me well here, if you see any, let's say, uh, coherence with what you say, you're damn right. And if you see any parallel with what SSP is providing, you're right a second time. Yes, we will provide this kind of platform that is solidly anchored on standards like SSP and FMI and Modelica for sure. So this is where I wanted to drive this as a conclusion. Like we are building a big simulation platform, and SID was only the first step of that. But we are building that on solid basement. That is Modelica. That could be SSP and EFMI and FMI and so on. So this is all part of uh, Dassault System DNA right now. This has been fully integrated, and we are leveraging that up to other activities where we can provide new offers such as FEM or 3D or all other activities. But you see that the simulation we are providing is definitely based on what you see on this picture. So this was a sort of let's say opening conclusion where you see where we want to go and what is the ambition that we do have. Let me thank you all for following us up to there. I hope you enjoyed the presentation and we could meet virtually in the booth. In the meantime, please take care and talk to you soon.